Good evening, everybody, and welcome to our fourth session at Mashpee Clean Waters. The first three, we've talked about our nitrogen problem, how shellfish helps, and how taking care of the land takes care of the water. Join us in 2 weeks. We'll be talking about financing alternatives. And today, we're going to be discussing the existing wastewater treatment facilities in Mashpee. It might surprise some people, but there are actually quite a few. And they're scattered throughout town. I've personally been able to visit an older plant in Hyannis as well as a newer plant that treats Mashpee Commons, and having the knowledge and experience has very much changed my kind of thoughts and opinions on that. Today we will hear from Tom Fedallah. Tom is chairman of the Mashpee Board of Sewer Commissioners and the town planner in Mashpee for 34 years. And so with that, I'll hand it over to you, Tom. Thank you.
Okay, thank you. So yes, I'm going to go to my first slide here. And I thought this would happen. Unfortunately, you guys are in front of things, but we have all of these wastewater treatment plants in Mashpee or adjacent to Mashpee. And again, it's hard with everybody being on the side there. Wish I could get rid of that part. But Mashpee Commons.
Tom, just on the pictures there, just put your cursor at the top and just make it a single picture, or you can put the little, click the line and you won't see anybody's photo at all.
I mean, hide thumbnail video. Oh, good. Okay.
Okay.
So now hopefully everybody can see the whole screen. We have a dozen treatment plants, existing treatment plants in the Mashpee area. Mashpee Commons, as was mentioned, there's different types too. So I'm going to go organism here by the different type of processes. There's membrane bioreactors, which is the state-of-the-art, best technology. Mashpee Commons and Cotuit Meadows have those. Mashpee Commons is located here, and all this white area and the gray area, the striped area, is within Mashpee Commons as service area. So you can see there's a chunk of the town that's served there by their treatment plant. And Cotuit Meadows is a treatment plant that's actually right there on the town line with Barnstable. The project is in Barnstable, but yeah, this area is sewered by that plant. There's one sequencing batch reactor, which doesn't seem to be working too well at the Mashpee High School. So that's basically this property here. The majority are what's called rotating biological contactors, RBCs, and most of the big condo projects and shopping centers that developed Mashpee Commons was originally an RBC. This is a fairly simple technology to get you down below 10, but it doesn't get you to the kind of best numbers we need. They're at Mashpee Village, which is the newest plant in town, located covering this area. New Seabury, their plant is located down here and it covers the white areas plus the growing development in the off of Rock Landing Road. Southport, which is this big chunk of land here, that's an RBC plant. Wampanoag Village, this crosshatched area here, the treatment plant is built, but it hasn't been operated yet, except to test it because there's no flow. The project houses aren't built yet. They're under construction. There's a type of process called Amphidromic, which is a brand name, but 3 of the projects in town use them, and they tend to be not the best. Southgate Village has one. They're obviously located here. It's actually, well, I'll show you later. It's under the parking lot. Stratford Ponds covers this whole area here with their Amphidromic. Windshine Point as an Amphidromic, and this chunk of land here. So you can see from the white, there are significant areas of Mashpee that are already sewered, but they're just not sewered with other municipal facilities other than the high school, although it takes the waste from the high school and also the Breezy Acres and the 10-unit housing project behind that. And finally out at Joint Base Cape Cod, which is actually in our watersheds, although the discharge goes the other way. They use a more old-fashioned process, modified Lutzak Ettinger. You'll see what that looks like. So next slide. Let's see. Okay, so as I mentioned, the type of project, the type of facility that Glenn saw at Mashpee Commons, and I was there as well, is a membrane bioreactor. This is just a simple technology sketch. It's basically got a bioreactor tank where there's biological processes that go on. Once that happens, it goes through a membrane system where things get physically filtered out, and the clean water goes out to treated effluent. There's also some recirculation possible. Cotuit Meadows has one of those, and this is the technology that town is proposing. A little more detailed diagram here. One of the things about the membrane bioreactors is you have to do a lot of good screening at the beginning. Some of the other treatment plants are just sort of basic screening, and water can go through the process without clogging anything up. But you need very good screening with grit and whatever else is coming through your system here. Then there's this secondary treatment in these tanks, pre-anoxic and aerobic zones, and then the membrane bioreactors. And then after that, you go through disinfection and flow metering. Disinfection for all the plants you're going to see in Mashpee is going to be ultraviolet light. Ozone is very difficult to manage and fairly expensive. Chlorine is not used in any of them because they all, the effluent all flows to water bodies where chlorine is very detrimental to salmonid fish, trout, that sort of thing. And so all the plants use ultraviolet light. And the only maintenance on that is you got to keep them clean and, of course, replace the bulbs when they burn out. And then every plant's going to have residuals that have to get handled, and everybody in town ships theirs off Cape. I don't think there's anybody sending theirs to Barnstable, but there's a place in Blackstone Valley that takes septage along with these solids, and they're basically the same thing. So it's like the septage of the fancy treatment plant. And just to show you the way that what these membranes are, is they're on racks. They're narrow, they're little straws basically on racks. There's a vacuum applied to them. And if you can see here, the brown stuff is the dirty water. Only the clean water gets sucked through those little pores that are in those membranes. And that's what goes to the leach field. Everything else stays in the system and either breaks down because of biological action or ends up being part of that stream that gets put into sludge. So this is a picture of the Mashpee Commons treatment plant. It has a permit for 180,000 gallons per day. Now, with all of these private plants, except with one exception that came later, when they were designed and built, the DEP used the same standards in terms of flow per bedroom or per other things that they have in their books as they do for your Title V septic system. So for example, every bedroom in your project is counted as 110 gallons per day. So they had all of that up, and that's how you figure out how big your plant's got to be. But as you can see, even on August peak day, for example, Mashpee Commons was at 54,000 gallons, nowhere near the 180,000 gallons maximum capacity. So it's very typical of all of these plants that the actual flows, even the peak day flows, are going to be a lot less than the permitted flow. And talk about good treatment. This is a membrane bioreactor. They are achieving 2.8 milligrams per liter nitrogen. That was their result in August, which again is one of the peak months. Their DEP permit limit is 10 milligrams per liter, which was set as a drinking water standard. But believe it or not, the 10 milligram per liter drinking water standard is about 5 times as high as what the bays can handle in terms of the environmental impacts. And they discharge to sand filter beds, which are these beds behind the plant here. And you can sort of see it, but their sludge holding tank is here, and this is actually like a little fire hydrant. That's what the trucks that come once a month or so take the sludge away, hook up to directly. So there's no opening of a big hatch and all the stench comes out and all. It's a direct connection, and so no smells. So this is basically state of the art at Mashpee Commons. What those sand filter beds look like, and those are used at the Commons at Joint Base Cape Cod. The ones at Joint Base Cape Cod are at the end of a 10.5-mile pipeline next to the canal. And then the proposed town treatment plant used basically what is just a big sand bed. The effluent gets basically pumped out onto the sand, and it just filters down through the sand into the aquifer and heads out to the ocean. It's the simplest, and it's the easiest to maintain, because what happens with these systems is there's still some biological activity, or there's, you know, seeds landing on things. You get the vegetation. It's very easy to just rake these beds to keep them clean and keep them unclogged. Other types of discharge are harder to maintain. So that's why we're using that in our proposed plant. Cotuit Meadows is the other MBR plant in town. As you can see, this is actually the town line here, and there's where they put their plant, right on our town line. That's the plant. These are houses within 75 feet of the treatment plant, and actually some of the treatment processes in tanks right here in between the building and the houses. In June of 2013, now I got all of the data in terms of the quality of flow of discharge from these plants from Glenn Harrington, the Board of Health agent. He was obviously doesn't get the results for Barnstable. So this is located. We don't have any flow data or quality data, except that we know that the permit for this plant is 59,000 gallons per day. The last number that I had in any of my records was from June 2013, where it was at 4.6 milligrams per liter. They have a limit where in recent years, because of the nitrogen problems in the bays, the state has come up with, there's the 10 milligrams per liter, which is the drinking water standard. Plus, they need to be zero net nitrogen for the project, meaning that they had to treat their project, which is a 40B high density housing project, to the best they could, and that's why they used the MBR. But they also had to tie other properties into their treatment plant. And in this case, the nursing home that's just to the west of this project on Route 28, and it's in Mashpee. It's a 90-bed nursing home. That is actually tied into this treatment plant in Barnstable. The office complex between the nursing home and the 40B project, the town line, Shellback Place it's called, that also has the rights to tie in. I don't believe it's tied in. They do subsurface leaching under a playground, which is out towards Route 28 off the map here. And what that is basically very similar to what most people's leach fields are these days for your septic system. It's basically a perforated distribution pipe, or in the case of these larger plants, a whole series of those perforated pipes covered in an area with rock, so that there's a lot of good discharge, doesn't get clogged, and then backfilled. There's a barrier material to try to keep the backfill, which is usually a finer material, from filtering into the stone, keep it clean. But you can see that ultimately there can be that kind of infiltration, and these things eventually need to be rebuilt. These are used at Cotuit Meadows, as I said. Mashpee High School uses this kind of discharge. Mashpee Village, Southport, and the Wampanoag Village plant on Meeting House Road also uses this kind of discharge. The next type of process, and then the only one in town, is called a sequencing batch reactor, and that's at the high school. It's basically a single tank that you runs through a number of cycles, an anaerobic cycles, where it goes from being aerobic to anoxic when it's filled up, and they drain it down, and the aerators are put on, and they aerate it again that's where the denitrifying happens, and then the sludge settles to the bottom, the effluent goes out. Now in this case, there's a further filter in the building, and it's an interesting building. This is actually, so this process I talked about, this long tank here, is where you were going through that sequencing batch process. Just look at this as being that tank. That's all open to the air here. These are metal grates over the top, and this is where they have their grit filters and all. And then it goes into this building. This part of this building has the final stage of treatment for the project. The rest of the building, interestingly, is actually storage for the ball fields and the equipment. So you have the treatment process laid out here. You have the small building here, and the discharge is by, as I said, the subsurface leaching, which is under this little bit of field here. In between, there's more recreation storage. So it's they're all jumbled together there. And apparently, and these are very sensitive to operation, sequencing batch reactors. They're not doing too well as of, these would all be last March. See again, the 18,000 gallon per day permit. Now, originally the state was going to require 24,000 gallons per day, but the health agent at that time was able to talk them down to 18,000 based on other schools. And again, they hardly ever hit anything close to that. But look at the nitrogen. It's 33.5 milligrams per liter. It's way in excess of even their 10 milligram per liter state permit. There's a lot of things apparently wrong with that plant right now that need to be fixed. And again, it needs a lot of maintenance, so maybe the town's not spending enough money on maintaining it. I don't know. Next type of process is what's called a rotating biological contactor, and these are at Mashpee Village. New Seabury has the biggest plant in town. It has 300,000 gallons worth of these. Southport is the second largest in town. Willow Bend, Wampanoag Village. These are fairly simple to operate. They're basically you're looking at this system sort of head on to what is basically a long row of discs that are attached to a central axle, I guess you'd call it. So the effluent comes in here, and on the discs, you get bacteria growing. So basically, I'm circling the wrong way. The disc cycles through here, and the bacteria that are on the disc in a healthy system, they do the nitrifying of your effluent in this process, in an aerobic process. You need oxygen to do that process. And from there, it goes into a submerged rotating process, and that's anoxic, meaning there's no oxygen, so that's where denitrification happens. And then this one shows going out to a settling tank. But for example, when Mashpee Commons was using RBCs, after this stage, they had a nitrogen filter, sort of a big sand filter at the end of their process before it went out to the effluent. So it's sort of a crude drawing, but it's the best I could come up with out of our technical. Now, these are all from the technology screening report, which was the first report that was done by our consultants for the watershed nitrogen management plan. It was completed back in 2007. Mashpee Village, this is what their building looks like. This is, again, the newest plant in town, Mashpee. Some people may remember it as Mashpee United Church Village. It's an affordable housing project on Old Barnstable Road. This is Route 151. So this is where the plant is located. This is where some of the outside tankage is located, and the discharge goes to subsurface leaching area down here. And curiously enough, again, you can see houses fairly close to it. I was actually standing at this guy's house when I took this picture of the plant in his backyard. This is actually the water district's Mashpee Village well. So we keep a good eye on that one. But that's the well where we actually had the oh, I hate when words pop out of my head. That highly permanent contamination stuff from the base. Somebody help me with that.
Oh, begins with a P.
Oh, PFAS, yeah, PFAS and PFOAs. That was contaminated by the Air Force, and so if you went there now, there's actually a third building here. When the well was bought from Mashpee Village, it turned out to have very high iron and manganese, and so this treatment plant was done at the cost of $2 million to clean up the iron and manganese. And then now that the PFAS is in there, this area has been cleared, and there's another building here now that just went into operation. It's a big charcoal filter that gets rid of the PFAS. So that is basically the most expensive well the district ever bought. And fortunately, I wasn't on the board at that time. It was a crazy idea. So this project has a 38,000 gallon per day permit. Their peak day in August was almost 18,000 gallons. Again, lower than what you think. And this one is doing pretty well. It's a brand new RBC process, so it's on 3.4 milligrams per liter, beating the 10 milligram per liter permit. And now, even though this is the newest one in town, it did not have the zero net nitrogen applied to it because it was not a new project. It was basically treating an existing neighborhood, no new housing, so there was no zero net nitrogen applied to this project. Nasiri, again, this is the largest plant in town, 300 gallons per day permit. Their peak flow in August was 48, almost 49,000 gallons per day. It's an RBC plant. RBCs are usually good for between 5 and 10 milligrams per liter. That month, the grab sample was at 8 milligrams per liter. And this is actually the plant here, the thing with the vents on it. This is a garage that was added later. So on this picture, this is the Nasiri treatment plant. And their discharge is subsurface discharge under these fairways, which were all torn up at one time when they were reconstructing and building this thing. And they have enough, they have 600,000 gallons worth of leaching under that, and they use leaching galleries. Now, next slide, I'll show you what those are. Leaching gallery is basically concrete chambers that get buried underground, and then the influent comes in, and there's usually stone that's underneath these chambers. I actually have one in my front yard for my septic system. Hate to admit it, didn't pump out my system often enough, so my leaching pit failed, and I had to get a expensive set of galleries under my driveway. These are also typically used when you're trying to do something under a parking lot. And get to Southgate Village, it also uses these things, but under parking. And Willow Bend has similar situation, but they use leaching pits, which are basically they're sort of, if you look at the well, whatever. Let me back up here. If you look at the storm drains that you have in Mashpee, and if you see them installing the leaching part of it, it's basically a big concrete pit type structure with holes around the sides of it and in the bottom of it. And that's how South Willow Bend gets rid of its discharge. It's a similar process. It's underground. In their case, it's under the driving range. Southport, again, it's a large plant, 172,000 gallons per day. July, their peak day was 78,000 gallons per day. It's an RBC process. Now, again, they didn't have very good results in July, 32.8 milligrams per liter. But their plant was under repair. They're actually in the process spending $4.5 million to repair and upgrade their plant. These plants have a lifetime, and this one has actually started construction in the mid 1980s. Was left sitting there for a number of years while Southport was in bankruptcy. and finally got completed in 1997 or so. So it's been there for a while. Their discharge is the subsurface leaching. Again, it was those series of pipes underneath this fairway right here. So there's the treatment plant, there's where the discharge area is, and this yellow line is a 500-foot radius around the plant, and you see a number of condos next door to that. Willow Band, that's what their plant looks like. Ugly building because it's not near anybody. It's 132,000 gallons per day permitted. Now, originally it wasn't. It was 112,000 gallons per day. But they, because they had a history after about 15, 20 years of use, were able to get that number increased in order to tie in the Cotuit Bay condominiums. So Willow Bend Treatment Plant treats Willow Bend. It also treats the Cotuit Bay condominiums, which are on the end of Quashnet or Quiniquisette Avenue, where it crosses the Santuit River. Doing pretty well. It's a well-maintained RBC plant. This month they were 4.54 milligrams per liter for that 10 milligram per liter. In this case, and there'll be in a couple of these, the planning board set us in their special permit for Willow Bend, set a limit of 5 milligrams per liter of nitrogen. So that is what the town and the planning board is pushing them to meet, and they're meeting the 5, so that's good. Again, they leach under your driving range, which is off the map here. Wampanoag Village, brand new plant. I don't know why it's 39,999 gallons per day, but that's the permit. It's usually just straight 40 is the way the technology works. It's not yet in operation. It was tested. As you can see, it was funded by the federal government for the tribe. Under their permit, the first 90 bedrooms that they build are exempt from having to be hooked up to the treatment plant, in which case it sort of will operate like a big septic system. Whether or not they don't bother to start the treatment plant, I don't know. After the 91st bedroom and beyond requires the use of the treatment plant and zero net total nitrogen for the project. In other words, tying other properties into the wastewater treatment plant. At the time this plant was developed, the land was not in trust as a reservation, and there was a plan to tie Town Hall and Zachary's and a number of all the houses along Meeting House Road into this plant in order to meet that zero net nitrogen. But if the federal reservation status is maintained and they win out in court, they'll continue to be exempt from all state DEP jurisdiction regarding the 10 milligrams per liter of total nitrogen or the zero net nitrogen for the project. And they could potentially add more houses on the property and run them through that plant instead. They discharge the subsurface leaching, again, those pipes under the field. In this particular case, the field is required to be kept open as a habitat for the turtles that were found out here, the box turtles. So a little different twist on the subsurface. It's not a lawn, it's a sandy area for the turtles. Now, Amphidromic is, this originally everybody thought this was going to be a good technology. It initially had some fairly good results. It's built at South Cape Village, the shopping center, Stratford Ponds condominium, and Windchime Point. It's a process that basically starts out with an anoxic tank. This is where the nitrifying process happens to the, and this is, by the way, this is an overhead view of what you're looking at down here. And this is the Amphidromic reactor here. This is where the denitrifying happens, and it goes into a clear well tank, and that's where the solids settle out, sludge settles out, and the water goes out that end. So it's fairly simple, but I got to tell you, this is actually right here. You're looking at the treatment plant for South Cape Village. It's actually under the parking lot. You see these metal covers. Those are where those various process manholes are. It's a 24,000 gallon per day permit. Their peak in August was 12,700. working pretty well. They're another one that has the DEP permit of 10 milligrams per liter, but again, a planning board special permit limit of 5 milligrams per liter. So they've had some rough spots in the past, but they've made extra effort and added an extra process to it. So you can see it's doing really well in August at 3.4 milligrams per liter. They discharged the Leaching Gallery, if you recall, those are those concrete things under the ground. So here's your treatment plant. This building here that you drive by as you're going into Roche Brothers is the control building for the process of the electrical controls. And then the discharge is actually under this parking lot here. Stratford Ponds, again, it's an Amphidromic process. Each of these plants each one is different. In this case, the guy that was developing Stratford Ponds at the time was a concrete guy, owned a concrete company. So he built his own tanks, and it's in a different configuration than some of the others. It's a 35,500 gallon per day permit. July peak day was 17,000 gallons. It's doing pretty well for an Amphidrome, 7.8 milligrams per liter. Beats a 10 milligrams per liter DEP permit. Now this one was built back in the late 80s, and at that time the planning board was just learning about the nitrogen issue, and everybody was talking nitrates for some reason, although they usually end up being almost everything that gets released in terms of nitrogen from the plant is in the form of nitrate. They set a special permit limit of 5 milligrams per liter of nitrates, which is not all forms of nitrogen, not total nitrogen like we're talking about the other plants. So they originally discharged to leaching pits between these condominiums here, but because they were going to be forced into doing a big upgrade of their plant when the Cotuit Fire and Water District located a well just south of them on that little finger of Barnstable that sticks into Mashpee, they ended up moving their discharge to a field that is just to the right of their entrance road off of Route 130. But again, it's right in the neighborhood. This is actually one of the condos right here. I was standing at a condo taking this picture. They just happened to have the operator there, so he let me into the fence, and this is what it looks like behind the fence. This right here, and this is a problem I've seen. I should have mentioned it at Southgate Village. When I was taking that picture, I was smelling the wastewater. And this particular plant also had odor problems, and this unit here is actually a big air filter that was added later to eliminate the odor problems from this particular plant. Same problem. This is the freakiest plant in town. Again, it's an Amphidrome. As you remember the drawing, there were sort of manholes here, there, and everywhere. Well, this one is up and down, and it's just incredible. It's just like a bunch of lumps with manholes on top of them. It's a 40,000 gallon per day permit. July, their peak day was 27,000 gallons a day. That process is all under here. This is just a control building. Again, it's got electrical panels to control the processes that go on in here, basically turning on and off aeration blowers. It had a state permit of 10. This one does have the planning board special permit limit of 5 milligrams per liter. So you can see right now they're not even meeting the state permit. They're double the planning board one. They have subsurface leaching to a leach field. This is where their process is. The control building's here. This is where their leaching is, just uphill from this field. And when I was here, I was smelling it too. For whatever reason, these Amphidrome plants, they smell. And any number of times I've driven into Southgate Village and smelled their plant. But as you saw, Stratford Ponds put a filter, air filter on their plant and eliminated the smell problem. Now, the last one I'm going to show you is the plant that's actually in place at the Joint Base Cape Cod. It's called a modified Lutsack Edinger process with oxidation tanks. This is a fairly old technology. If anybody of you saw the selectmen's meeting when Jeff Gregg was mentioning the technologies, this MLE is an older technology. It's got a 360,000 gallon per day permit, 154,000 gallon per day peak in June of this year, or that's May, I guess. This one has everybody at the base as well as the county jail tied into it. And right next door to it, just I wanted to include this. This is actually the systems test center that Brian Baumgartel, the chairman of the Board of Health, manages for the county. And these are all different types of on-site septic systems, denitrifying systems that are being tested out there to see how well they work. In any case, the total nitrogen in May was 7.3 milligrams per liter. Again, the 10 milligrams per liter discharge permit. There's a 10.5-mile pipeline that takes the effluent from this plant and brings it to sand filter beds, if you recall those from the beginning. There's 4 large ones next to the road along the south side of the canal. You can actually, if you know where to glance in, you can look through the fence and see them. This is the basics of that process. Influent. Within the same tanks, you get anoxic and aerobic stuff from the settling tank oxidation. This is the particular technology they use is carousel. So the water comes in, screened effluent comes in, it goes into an anoxic zone. It basically circulates around the racetrack here and goes into an aerobic zone. Whoops, I'll do that. Aerobic zone. So you get the anoxic where you get nitrification, aerobic denitrification, and it keeps going around and around and around, and eventually some of the effluent gets taken off and put in these secondary clarifiers. And if you go back to the picture of the plant, here are those carousel units here. So the water is going around and around and around and around here, and here are the aerobic units where the final process happens, and then it gets pumped way off the picture there to those sand filter beds. So this
Tom,
is
just to not interrupt, but a quick time check. It's 8:40, and we want to leave a little bit of time.
Okay. Well, I'll just blast through a few things here. This is the proposed treatment plant at Mashpee, the Mashpee treatment plant at the transfer station. There's the transfer station. This is basically the pre-treatment, the grit and all of that stuff. This is where the membrane bioreactors and those processes go, and then it gets put through those ultraviolet lights and then out to the 4 sand filter beds. And you can see the buffer that we left around the project and added a lot of understory vegetation, rhododendrons and things like that. There's the access to it, basically through the transfer station. DPW director demanded a construction access, so we had to break our barrier buffer for that. And there's that 500-foot radius. There's only one house here that's within 500 feet of that plant. So, end of presentation.
And that's thank you very much, Tom. That was really informative and interesting. And I think that last slide is a good one to stay on. And maybe I'll ask the first question and open it up. I was looking at the Berry and the Southport, Stratford Pond, and some of these other sites, and I mean, there's houses literally almost on top of those plants, and
right.
And some of those are very high-end neighborhoods. Do the neighbors know that they're there? Are they impacted? Can they smell it? Is it an issue?
Well, apparently in the one case of Stratford Ponds, they smelled it, and that's why they put that air handling unit in there to get rid of the smell. Yeah, you have in all of these slides, I haven't been pointing them out, but there are the same 500-foot radius. So here's the 500-foot radius around the plant at Windchime Point, and all of these condos are within 500 feet of it. We actually have a proposed new planning board member who lives right here in between. This is the Mashpee Commons 500-foot radius. So they've got a double whammy on these guys here. They're both within 500 feet of Mashpee Commons as well as 500 feet of their own treatment plant. Those are high-end condos at Stratford at Windchime Point.
And the Nasiri one, or this one as well. It's
just this one. Again, this one is the one that had the odor problem that got fixed with that air handling unit. But this is Stratford Ponds condominiums. They're fairly expensive condominiums, and there's lots and lots of within 500 feet. That's the same 500 feet you saw with our proposed plant I didn't have 500 feet on that one. I don't have 500 feet on that one. This is the, again, Southport, a lot of expensive condos within the 500 feet. New Seabury, dozens and dozens of condos. These are about 115 feet away from the treatment plant, this row of condos here. This is a 200-foot radius here. Yeah, and that's high end.
That's very interesting. So we have about 15 minutes left. I have a few questions I'd love to ask, but I'd like to open it up to anyone else who might want to ask questions first.
I'd love to. Hi, Tom. Thanks so much. That was really great. My first question is, who monitors each of these facilities? And when they are over the permit level of 10 milligrams per liter, what happens? Is there a fine, a slap on the hand?
All right, so each of these treatment plants is operated by a contractor, which is what we want to do with the town treatment plant too, rather than hire a lot of staff with benefits and all the rest. We need one person to manage the contracts, but everything else will be done through contractors, same as these. The contractors are the one that do the testing. They send the test samples off to a laboratory, and they're the ones that the labs tell them what they've got in terms of nitrogen and a whole other bunch of constituents that I haven't indicated here because we're focusing on nitrogen. And when they exceed their permit, if it's by a little bit, you know, they might get a call or even not. If it's oh boy. If it, let me get rid of this. Go away. All right. If it lasts for a while, they'll get a letter from DEP saying you better fix this or else. DEP in some cases, you know, is fairly strict, but I mean, I've seen issues not with treatment plants, but with the trailer park on Route 151, Lakeside Village, they call it now. They've had DEP enforcement orders on them for their gazillions of septic systems and within feet of their water system, and those went on for 15 years without DEP actually doing anything. And that's this guy Haney that lucked out by having the PFAS contaminate his well, and as a result, the Air Force paid for building the whole new water system in his development there that's now hooked to town Mashpee Water District water. So I haven't seen any serious enforcement there. Frankly, the planning board, at least in the past, Beverly Kane, when she was the chairman, she was very strict about having us get the reports every month onto the planning board agenda so they could keep track of those fives. And they basically hauled the developers, the owners of the plants into the planning board meetings and told them in no uncertain terms, fix that. And basically that job owning was more effective than anything I've seen come from DEP recently.
Thank you.
Thanks. One other question. It appears that Mashpee High School and Southport, which are adjacent to each other, or across the street from each other pretty much, are both having high output, 32.8 and 33.5 milligrams per liter.
Right.
And are they along the Quashnet River as well?
They are to the west of the Quashnet River. Yeah, they'll be in the Quashnet River watershed. Now, the reason that the numbers are so bad for Southport is, like I said, they're rebuilding their plant, $4.5 million rebuild. So there are portions of their process that are being bypassed at the time these results were gotten. So like I said, they have an excuse for being that bad. The high school, I'm not aware of anything going on other than it's not running very well.
Okay, great. Thank you.
Anybody else have a question?
I have a question. This is Gretchen. Thanks for your presentation. It was excellent. It seems like a lot of the properties have got a permit for so many gallons per day, and they're only meeting, you know, maybe half of that. Is there any way that more properties could tie in with those systems just to alleviate our present problem?
Well, that's an interesting question. I think I mentioned the reason that the numbers are so high in their permit is because they use the same Title V numbers, like I said, 110 gallons per bedroom, even if you've got a 4-bedroom house and only one person is living in it, in order to establish the amount of treatment that you have to have available. This is not a good example because it's a commercial thing, but I mean, Stratford Ponds, you know, that was based on the number of bedrooms in Stratford Ponds, and they're never fully occupied. A lot of these projects mainly have a big condo with maybe an elderly couple in it, not a lot of kids and these things, so they never come close to reaching that number. And the number itself, when the Title V was established, was actually, it was based on the worst possible day. It's actually much larger than even like your septic system. I have a 1,500 gallon septic system, so that was sized for a 4-bedroom house. I guarantee you never got to 1,500 gallons per day running through my septic system. But the thing is, you have to size it for, you're going to have a party or whatever. They don't want your septic leachate coming up through your lawn, which I've lived in places. I rented a place at Papaneset where, I mean, I was the only one there in the winter, but in the summer across the street, they'd have 5 cars and, you know, 10, 15 people, and the front lawn would just be sewage and it stink. So that system obviously was not designed under Title V standards, which came out in about 1980. But that's why you see those much larger numbers. And yes, one of the principal ideas in our thinking about wastewater is that there is this excess capacity, and after a number of years, say 20 years of proving that you're never going to get to those numbers, one of the things in the plan calls for is having the town take over the private treatment plants, particularly the larger ones, and the better, the higher quality ones, and using that excess capacity to tie in neighbors. Those are kind of things that have to be negotiated, but that is definitely something that has been in my mind since way back, since 30 years ago.
Great.
Thank you, Tom. Any next question?
Yeah, this is Mary. I wanted to ask Tom about, you keep mentioning zero net nitrogen. Is that something that's part of our zoning restrictions already, or
No.
did I misunderstand?
No, that is coming from DEP. So
Okay.
once these TMDLs for nitrogen were established in the bays, the DEP started enforcing this nitrogen sensitive embayment rule, which requires zero net nitrogen. So when you build a project, you basically have to treat your effluent as best you can, but that doesn't get you to zero. So in order to get you to zero, you have to take somebody else's lousy effluent, like in the case of this project, that 90-bed nursing home on Route 28 in Mashpee, tie it into your plant in order to reduce their nitrogen enough to match your additional flow, and so it's a net zero. So like,
Is that something only applicable to large-scale developments?
it's only been applicable in recent years. So older projects did not have this applied to them. It wasn't until those MEP reports and the TMDLs were established in like 2008, 2009, that plants that were built after that, after those bays were shown to be nitrogen overloaded, that they started enforcing this rule. And the rule didn't come into effect until probably after 2000 to begin with. So it's only for these most recent plants. In this case, you saw Cotuit Meadows and the Wampanoag treatment plant. Again, if that one went back to being subject to DEP. And
Is
as I
there,
said,
Tom, is there a scale? Like you have to be a certain size in order
No.
to be?
no, well, here, any discharge that you have that's over 10,000 gallons from a project, you know, whether it's a commercial or a residential project, we have more than 10,000 gallons per day of wastewater flow. You have to get a discharge permit from DEP. And that's basically the permit to inject the stuff into the ground. And it's through that discharge permit that they establish those 10 milligrams per liter nitrogen and the zero net nitrogen, all that stuff, which means you've got to do a treatment plant because septic systems won't come close to that. 25, 30 milligrams per liter nitrogen
I got it.
septic systems. So it's everything over 10,000 gallons needs a discharge permit and therefore probably has a treatment plant.
And so I just point out that Mary Wagon shared in the chat the Massachusetts law that requires land use controls in order to get the, I assume when you talk about 0% financing, you're talking about the financing for the new treatment plants.
Yeah, that'll be a good thing to talk about at your next meeting because that was sort of brushed over at the selectmen's meeting the other day when they were talking about getting all of that zero interest money. But you have to have basically, it's almost like a zero net development bylaw in place, which we don't have. We just went the other way when we added all those accessory 2-bedroom houses to, you know, anybody's lot if they want one.
And that's a good segue that I'd like to jump in for a second. I think zero nitrogen, of course, is a great objective. But if you look
It's
at
not zero, it's zero net for a project.
Zero
There's
net.
still nitrogen going into the bays, but
and it's a good segue to the town's plan, because if you look at Papaneset Bay, the threshold is 13,852, and the current load is 31,961. We're 18,000 kilograms, or 131% over the threshold. So while zero for new things is good, we actually have to take out more than 50% of what we're already putting in, which, back to you, Tom, I believe is why we're proposing that the town get its own treatment plant and not just continue to have these private ones.
well, yeah, I mean, zero net sounds good, but all that means is you're staying at that 30,000, you're staying polluted.
Yes.
You know, it's not like, it should be a negative number, not a zero. And so the only way we can make it negative, since these private plants aren't required to do it, is to treat all those people that are on those septic systems that under the MEP studies, they estimate about 26.5 milligrams per liter nitrogen in the effluent from a perfectly well-working Title V septic system. You got to get those down to 3 milligrams per liter, which is what we're trying to do with these treatment plants. So that's why, as you see in pink here, this is the first phase we're talking about for a collection system along the east side of the Mashpee River. The light blue is the second phase. So you can see that basically that takes care of the Mashpee River and a good chunk of Papaneset Bay. And over here on the west side of town, one of the watersheds we can't take care of without sewage is the Quashnet watershed, which basically runs this whole chunk of town. And so we really got to do sewering there. There's no other way. There's no shellfish. Hamlin Pond, as you see here, Hamlin, Jehu Pond, Little River, Great River. Rick can tell you they'll do 100% of the removal of the nitrogen that has to be removed to meet the targets. In the Mashpee River and Shoestring Bay, he figures he can get 50% reduction with his oysters out there. But that means we still have to do sewering here, and because there's no treatment possible, no shellfish possible in the Winnicus Estuary or the Quashnet River, we got to do a lot of sewering over this part of town.
We have just a couple minutes left. So apologize for the interruption. There, on the chat, there's a question asked if we could adopt a zero net requirement in the town zoning bylaws.
Well, in terms of wastewater treatment plants, the ruling authority is the state. And, there's this thing where unless the state lets you, you can't invade their territory, so to speak, in terms of regulation. So treatment plant nitrogen regulation is through DEP, through the state. We couldn't do a zoning bylaw that said your treatment plant, has to do 5% or whatever. Because those other projects needed special permits, which are discretionary, the planning board was able to say, look, if you want this project, you have to do 5 milligrams per liter. So that's how they get that part. It's not just a general zoning bylaw that says everybody has to be, 5.
That's for projects, but I think I've seen some potential bylaws out there on the Cape. I'm trying to remember, maybe it was Bourne or somewhere, where they started to say, any new build would have to be zero net, not just a project, but particularly close to sensitive waterways.
Well, I mean, that basically that's, I haven't read that legislation that Mary's put up there. Mary Wagon has recently, so we need to dig into that, because that's going to involve passing some bylaws at town meeting, hopefully next May, if that's when we're going to start talking about funding this process here and getting SRF loans for it.
I'm sorry, go ahead.
I was just going to say, I know Andy Gottlieb's well aware of that. I don't know if the other selectmen are aware of that. They hit him like a bomb.
Yeah, it seems, I'll make a statement and then one last question and we'll wrap up. It seems like if we're already 131% over the load, that we shouldn't be putting any more in unless we, are putting the infrastructure in to take it out. It seems like common sense to me. I'd like to ask one last question before we wrap up, which is about distributed versus central. It's in Mashpee today, it looks like we have a very distributed footprint of these plants. And if you look at infrastructure, whether they're power plants that used to be built one massive power plant, but more and more we're seeing distributed smaller systems as technology evolves. And it looks like to me Mashpee's plan is to build this a more distributed system as opposed to rely on a single plant, which is coming up potentially at joint base. But do you have any thoughts on the pluses and minuses of a distributed system versus one single huge system?
Well, we are by default distributed because we have all of these private plants. Nobody wants to tear them down and replace them with a big central plant. Back in the late 80s, around 1990, there was actually a wastewater management plant. It was called a draft wastewater management plant done for the Board of Health by Weston and Sampson. That went through all the possibilities of town, and they said, bad idea, central treatment was a bad idea because the majority of the cost is in the collection system. And if you put everything in one spot, you got miles and miles and miles of pipes to move things. So they created this term sub-regional treatment plants, which is, we don't call them that, but that's basically what we've got. We've got, the Site 4 plant for this area. We've got the Site 6, which is actually where that cell tower wanted to go down in New Seabury, but with effluent pumped under the New Seabury golf course, and then either Joint Base Cape Cod or our own back road sites here to cover the western part of town. And again, these other larger plants would still be operating, so it would have multiple treatment plants. So yes, it's a distributed system. And right now it's like massively distributed because everybody's on, most people are on septic systems.
That's true. No, but you hear that the trends in electricity generation are more and more distributed, and as technology advances, it allows for small scale, and distributed systems also have benefits in terms of if it fails, the whole thing doesn't fail. But moving on, I'd like to go to the last question. Nicole Corbett asked to jump in quick, so Nicole, please go ahead.
Oh, hi. How are you?
Hi.
Hi. So I've actually been testing the water at Papaneset Beach for the last 2 months and sending the results to the Center of Coastal Studies regarding the nitrogen concentrations, phosphorus concentrations. They're currently running chlorophyll in a couple of the tests right now. The inorganic nitrogen getting in the beach water is actually averaging around 0.05 to 0.06 at low tide. 0.14 is considered the most compromised an estuary like that can be, but it looks like that the water, like some of this stuff may actually end up like impacting more than just the bays and estuaries. You're probably going to start impacting the beach water as well at some of the town beaches. South Cape Beach looked like it was having similar issues this summer as well. I wasn't sure if that's something that is also being looked into, if mostly the bays are being focused on.
No, the focus is on the bays because the numbers are really, really high. I mean, the clean water, we're counting on to come in and flush out the bays is what's out in the Nantucket Sound. But the way the groundwater works there, of course, the groundwater, what you get off the beach is actually fresh water coming up through the through the bottom. And what's been noticed over the years, we used to have a lot of eelgrass in our bays. That's what we're trying to achieve to restore. That's actually the basis for the restoration numbers for Cotuit Bay and Papaneset Bay, is restoration of eelgrass back to the way it was in 1951.
Right.
Now you're getting, never had it before, you're getting eelgrass off in Nantucket Sound, off the beaches, because there's enough nitrogen for it to survive out there.
Yeah, I've seen it washing it. When we were out sampling, we've seen it dead washing in a lot now, just like the big chunks and taking the whole root with it.
You know, back in the 1980s, that stuff was floating all over the bays, and everybody's complaining about getting clogged in their, motorboat crops and all that stuff, including me. But now we miss it because that's sort of where your scallops
anchor to.
Scallops attached. Yeah. So no eelgrass, no scallops. And I love my scallops. That's why I've been at this for 30 years.
Yeah, no, I was interested because, I was actually kind of surprised because as the sampling's going on, I mean, we had the massive bloom of brown algae that just took over that whole beach over the summer. So as we're kind of like going along, the nitrogen levels look like they're actually going up now that cleared out, because that algae was taking in all the nitrogen. So I was just interested if anything was being looked at by the town with in regards to the beaches, but I know the bays are mostly the primary focus.
Yeah, I mean, at the time we started this project, there was no problem at all at the beaches.
Right.
It's just, this project, the study originally got funded in 1999 by town meeting. We got talked into going for a SRF loan from Andy Gottlieb when he was actually running that program at the state. So we went back and applied for a loan, and it took us about 1.5 years to get the zero interest loan that we used to fund the study. Back then, think of it, that was 20 years ago. We've had 20 more years of development, 20 more years of stuff that was built up in the upper part of the watershed, getting down to the bays and to the ocean. So that's the problem's only got worse in the last 20 years, and certainly in the last 30 years, because we built more stuff and there's more effluent.
Yep. And that's a good place to wrap up. Nicole, I think it's a good point. It's getting so bad that it's not just the bays, it's actually impacting the beaches. I'd like to just kind of summarize a little bit, and we'll finish up. It sounds to me, we have a number of treatment plants across town. It seems that if they're done well, particularly with RBC technology, they work quite successfully.
Our RBC is not, it doesn't get you down low enough. The MBRs is what we need to do.
MBR.
Yeah.
Get you down to that 3.
Bioreactors. That's those little straws. That'll get you to 3 and below. That is sort of the limit of technology, the best technology. The RBCs aren't designed to get down that low, although some plants add a denitrifying filter at the end of the process to get it below what the RBC does on its own.
So if done correctly with the right technology, these things work. It sounds like if we didn't have the plants that we have today, we'd be even worse than the 32,000 kilograms and 130% over.
Well, let me just make one point. All of these treatment plants that you see in town, other than the high school, although that's a new project, every single one of those plants is there because the developer of those condo projects got a much higher density of development than they would have under the normal zoning. So, Southport would have been 1 acre or 2 acre lots, single family homes with not 750 condominiums. So it's not like, it's a great thing that they built that project with a treatment plant. It may have been better off if it was just under the regular zoning and didn't get the high density development that you got there and all those other condo projects. So, you know, this will come up when we're talking about taking over the plants, whether or not we have to pay for them or something. Well, I mean, they're there because the projects were allowed to be there, and that was a condition of the project happening at those high densities. So something to keep in mind when we're talking about Mashpee Commons and everything else. They're not doing us any favors by building more development, even if they got a good treatment plant, because that's still more nitrogen.
Yeah, I think that's a really good point, and I appreciate that. I think we talked about. We'll wrap this up. We have to be taking nitrogen out, not putting it in. There's too much of it. But when it comes to the town's plan and the town's proposed treatment plants, these seem to be in dense neighborhoods, in high-end neighborhoods. The smells appear to be manageable. They're very close to homes. So it's been really helpful. There's no doubt in my mind that we can do better. There's no doubt in my mind that, and you just look at the threshold, that we're way over the threshold, and we obviously have a serious problem. So I agree that the plant shouldn't be celebrated as a success, but I do want to recognize that they do make things better, and it looks to me like we need more. So with that, I'd like to wrap up and thank everybody. And Tom, that was a fantastic presentation.